Good morning, friends of chemistry. Good morning, Martin.
Yeah.
So polite. Could you say good morning?
Good morning.
Fine, thank you. You're doing on your own 11.6, which is found on page 369. Okay. So in this section, they introduced to you a new concept called molality. Okay. Sounds a bit like molarity, but it's different. Molarity, as we remember, is capital M, and it's the number of moles per the number of liters of a substance. Okay. This is different. This is molality, small m, and it's the number of moles of solute per the number of kilograms of the solvent. Okay, so two different substances that we're measuring. So, as they said in the book, they're not really explaining to you why you need to know molality yet. They just want to make sure you're able to calculate this. And in the next section, they're going to explain the concept. So, I'm not going to worry about what is molality, why do we need to know it. You'll learn about that in the next section. But right now, we're just going to calculate the molality of these substances. So, Martin, please read 11.6 to us.
11.6a.
Right, well, what does the top say?
Calculate the molality of the following solutions.
Good, so I wrote them down here. 2 moles of NaOH and 1.2 kilograms of water, 25.0 grams of KNO3 and 2.43 kilograms of water, 34.5 grams of NaBr and 578 grams of water. Okay? So
the top is easy.
Letter A is easy. In order to calculate the molality, we take the moles of solute divided by the kilograms of solvent. And that's the units that they've given us. So we're going to easily be able to calculate letter A. We're going to say the molality is equal to 2.3 divided by 1.2. Okay? So I'm not going to worry about the units. We don't really need them. Did you do that? Yes, you did. Martin did that, and he got 1.91666. How many digits do we want, Martin?
2.
2. So we're going to say 1.9.
1.9 molality.
1.9 molality. Okay, it looks like meters, but we're not working with meters, and you know that, so I'm not really going to worry about that. All right, so that's letter A. Okay. How about letter B? We don't have the number of moles of the solute, but we can calculate it because we can figure out the molecular weight of KNO3.
K is 39.1. N is 14.0.
And oxygen is 16.0 times 3 is 48.0.
Mm-hmm.
5, 6, 4, 10. So 101.1 grams per mole, or 1 mole per 101.1 grams. Okay? So what do we know? We know how many grams we have, so we can figure out how many moles we have. Which conversion unit are we going to use, Martin?
Moles to grams.
That's right. So we're going to say 250.0 grams times 1 mole per 101.1 grams will give us moles. Martin's going to do the calculator calculation. This isn't a very difficult mental or
It's 25,275.
I'm sorry, did you divide 250 by 101.1? You see how it's set up here and do the correct calculation.
Okay, it's 2.5. We can use 4, right? No.
Yeah, I want 4 significant digits.
Okay. 2.473.
Okay, so I see we got 2.473. 279, so 2.473. Okay, see, we have 4 significant digits. 4 here. All right, so that's how many moles. Now we're going to calculate the molality. Oops, let me add. I didn't finish my calculation here, but I could. I'm not going to do it now because Martin told me the answer already. So the molality is going to be the number of moles of the solute, 2.473, per kilograms of the solvent. And the solvent
2.43.
is 2.43. So it's almost going to be 1, you can see.
Yes.
Right? It's going to be a little bit more than 1. What is it? 473 divided by 2.43.
2.43 is 1.08.
So it's 1.0. Can I see that? You're reporting it incorrectly. It's 1.01, not 1.08.
Oh yeah, 1.01.
It's one. Listen, when you're giving me the calculator number, don't do the rounding.
I was misspeaking.
I understand that, but you did do the rounding because you were saying 8 instead of 7.6. Okay, so 1.01769. Okay, so how many digits do I want? I want 3. So 1, 2, 3. So I'm going to record it as 1.02 molality. Okay, that's the answer for letter B. Letter C is going to be very similar. Okay, I'm going to find out the number of moles based on how many grams I have. That's letter B. So
NaBr. Na is 23.0. Oh yeah, bromium is 79.9.
okay, so I add that up.
That's
I want to have to the 10th place, so I'm fine. And it's 102.9 grams. So that tells me I have 34.5 grams. I'm going to multiply this by 1 mole per 102.9 grams. Grams to cancel. I'll end up with the correct number of moles. So divide 34.5 divided by 102.9. We get 0.335276. Okay, so I want to have, here I have 4, here I have 3 significant digits, 1, 2, 3. I'm going to record that as 0.335 moles. Okay, so now I can use that to calculate, oh, wait a minute. What's wrong with this, Martin? It's not terribly wrong. Do I have kilograms?
No.
No. So I need to do another conversion.
So
it's going to be easy.
0.578.
I just divide this by 1,000. 1, 2, 3. All right, 0.578 kilograms. So I'm going to divide the molarity. Everyone see this? Yes, molarity is molality 0.335 divided by 0.578.
Which is 0.5795847.
Okay, how many significant digits am I looking for?
4. No, 3.
3, yes, because I have 3 and 3. So I want 1, 2, 3. So I'm going to make this 0.580 molality. Okay?
That's the end of the video.
That's the end of the video. Good job. No more chemistry for today.